We're going to talk about imaginary numbers. So yesterday when we were talking about radicals, we talked about some scenarios we knew could not happen with radicals, and we addressed one of them. What was that one we addressed yesterday? Can't have radical in the denominator, absolutely. So there's one other major issue with radicals that I want to talk about today. Do you know what it is? You're absolutely right. No negatives under the square root, right? Why can I not have that? Nothing times itself will give you a negative number, right? Because if it's exactly the same. So do you agree that if some way I could get rid of the negative, it might make the problem a little easier? I might be able to solve it or simplify it, right? If I could just get rid of that negative and replace it with something. Well, that's where we get into imaginary numbers. We're going to let this little variable I represent the square root of -1. Okay? So, if I see a negative, yes. If I see a negative under a radical, like this, I'm going to look at it and say, well, I know the square root of -4 can't happen, but again, if I could take that negative off, do you agree that I could write that way? That was one of those properties we talked about yesterday, which means I could also break it apart, right? Are y'all following me? That way, I'm just going to replace this with the I, and I'm going to say that this is going to equal 2I.
Where did you get 4 from?
I just started with an example of -4 under the radical.
Wait, how did you get that?
If I let,
that says 2I.
2I, yeah, plus or minus 2I. So all I'm really doing is replacing any negative under the radical with an I, and then going forward from there the same way I've been doing. Does that make sense? You have to keep in mind as we work through some of these problems that I is always the square root of -1. So, let's look at another example. And it follows the variable just because that's good math manners for our variable to follow our coefficient like that. Let's say I had the square root of -12, and I was asked to simplify that. What do you think we would do? Let's don't all answer at once now.
I mean, what about the I?
-1, that's right. Grant said -1, and I would definitely do that. So I've got I times the square root of 12, but it's still not simplified. Wait, what?
Where'd the negative go?
-1 times +12 is -12, right? I can't have a negative under the radical, so I took it out here. And I've got to remember that I is always...
So you really didn't do anything?
I really just wrote it a different way, but I replaced the negative with an I is basically what I did. Does that make sense? I'm not done because it's not simplified. Why is it not simplified? 4 and 3, absolutely. I got square root of 4 and square root of 3. That's right. I'm going to write 2I square root of 3 just because in general it always follows that coefficient, that whole number coefficient like that, the variable does.
Minus 2i's first.
Does that make sense? That's a fairly easy concept. Do we agree? So if I took one of our warm-ups like we had first thing, let's say I had 3x squared minus 8 equals -23. And I needed to solve that. Again, my first step is to do what? Come on, Sad, map it. Add what? 8. What's -23 plus 8?
16.
I was about to say.
That's what I said. I just said put the negative in.
Oh, okay, Moon.
But y'all know what I meant, though.
Yeah, we know what you meant. Now what?
Divided by 3.
So now I've got x squared. Remember whenever we did this before, we had x squared equals 5. Now we've got negative 5. The only difference is, yep, instead of my answer being plus or minus root 5, it's now plus or minus I square root of 5.
I got it.
Does that make
Because
sense?
the I is basically the negative part of that.
That is correct. Now, of course, we're going to build on this a little bit. That's not all there is.
Same thing, but with an I.
So this will apply to everything? No.
Yeah. We use imaginary numbers to make what we call complex numbers. So a complex number has two parts, hence it's complex. It has a real number part and it has an imaginary number part. And I either add or subtract that imaginary number part. So, for example, 3 plus 2i. Complex, yes?
Yeah.
Real number, imaginary number. 6 minus 2i. Complex, right? Because it's got a real and I know this seems very easy, and it is, but of course we're going to do some more with it. What if I asked you to combine two complex numbers?
You'd add
Both of
what
those are complex because it's got a real part and an imaginary part. This is real, this is imaginary. Together they make a complex. All right, Tanner, say again. What'd you say? Let's say I wanted to add them. Can you add complex numbers?
Yeah.
Sure. Tell me what your gut's saying you should do.
Add 6 and 3.
Add 6 and 3, you're absolutely right. Then what?
Add 2i
Oh, this was like a...
Oh, I get 0i, which is just 0, so I just get a real number back out. That doesn't happen every time. It just happened to do that this time. But the point is, we combine what goes together. We basically combine like terms. Be careful if you're subtracting, because when you subtract, just like if I were subtracting two binomials, I would be subtracting everything in parentheses that follows. Ah! Oh, it went away altogether. Where is it? And we're back. Okay, let's say here, I made this subtraction instead of addition. Understand that what I'm subtracting is everything that follows that subtraction sign. Right? I'm subtracting, so if you're a same change person, I don't know if you are, I'm not a big fan of same change because it changes everything that follows the subtraction sign there. This one stays the same and we're subtracting both of these. So what is 3 minus 6?
Negative 3.
Negative 3. What is 2i minus negative 2i?
0i.
4i. Minus a negative. It's going to add them together. Does that make sense on the... I'm not going to bore you with the addition and subtraction because it's pretty easy. But the multiply is a little bit different. And then we're going to rationalize denominators with them and then we'll be done. All right, let's look at multiply. Multiply. Complex. Numbers. Let's take our 3 plus 2i and let's multiply it. Let's make something different. Let's say 5 minus, we'll do 3i this time. If I needed to multiply these, now I'm going to assume it's fairly easy for you to start out with the multiplication here, yes? We've been multiplying binomials together for a while. So 15.
And then negative 3. Oh, okay. 15 minus 9.
9i, that's absolutely right. Next term,
That's 10i.
that's 10i.
And that is 6. Negative 6i.
Close. Negative 6i
This is,
squared, right?
why is this
If x times x is x squared, I times I is I squared. Do you agree with that? What is it? 15 minus 9i plus 10i minus 6i squared. Where are you looking?
Negative 9i plus.
Oh, okay.
You with me? Okay. All right, now think about this with me for just a minute. Obviously, I can combine the like terms in the middle, yes? We all agree with that?
So 15 plus 9.
But I want you to look at this for just a second. I want you to think about it with me.
So that's just it.
If I is what?
It's just
It's just it twice. If I is the square root of negative 1,
so negative 6 times negative 1.
what would I squared be?
Regular I. Positive?
-1.
Negative 1. Remember my opposite operations? These are going to cancel out. So if I square that, and I get negative 1.
Well, I squared equals
Does that make sense? So think about this when it's hooked to a number. I don't know what that was.
Somebody's phone.
When it is hooked to a number like that, what is it doing? Let me write it like this. Let me write it out step by step because I really want you to see what's happening. What happened to that 6? It is positive now, so essentially what did the I squared do to the 6? It flipped the sign. It changed the sign on it.
Okay, so instead of it being negative times a negative, it would be positive.
Will you go back up real quick?
Yes.
So I can see what you did.
So anytime you see an I squared hooked to a number, all it's doing is changing the sign of that number because it's really a negative 1. Okay, so negative 3i squared is going to be what? 3. 10i squared is going to be
Negative 10.
negative 10. That's all it's doing. We're dropping the I squared and changing the sign of the number. Does that make sense to everybody?
It's a negative times 10.
Correct.
It's negative 1 times 10.
Correct. Okay. Keep your answers real number and then the imaginary number that follows because that's standard form of a complex number. We want to keep it like that. All right, so that's multiplying. And I would do another example, but I think you'll see when we get into dividing, we'll do plenty more multiplying and you'll have plenty of practice with it. So, yes. There's 2 scenarios I want to talk to you when we divide complex numbers. Actually, let me do divide imaginary numbers first. And if you think about this, we've really already done it. What's the difference, first of all, in an imaginary and a complex? Exactly. A complex is made up of 2 parts and an imaginary is one of those parts. Imaginary has just got that square root of negative 1 in it, okay? So if I'm dividing just by an imaginary, 5 over 2i, what is wrong with that the way it sits now?
Is 9 in the denominator?
And why can't I have an I in the denominator?
There's no exponent.
It's a radical. At the end of the day, the I is holding the place of the square root of negative 1, and I can't have that in the denominator.
So it's basically like an exponent.
Absolutely. So what do? How do I get rid of it?
You have to multiply it from the bottom and the top.
By what?
Negative I.
I heard 2i, I heard negative I.
Negative
What's going to make it go? When we were doing, if we just had square root of 5 in the bottom, what would you multiply top and the bottom by?
by negative.
By itself, square root of 5, right? All you have to do is multiply by an I. You could multiply by 5i, but what's going to happen if you multiply top and bottom by, 2i? By 2i, you're going to end up having to reduce that fraction in the end. All you need to get rid of is the radical. So I'm going to put you a little note here. When you're dividing by imaginary numbers, you want to multiply the numerator and denominator by I. And watch what happens. What happens to the top? 5i. What happens to the bottom? Absolutely. 2i squared, which is -2. And there is nothing wrong with that at all. Does that make sense to everybody? What's wrong? It looks like what? Oh, yeah, this is easy. Complex is a little bit harder, but we've also already done that too. You're still writing? You need me to give you a second?
What's that say?
Let's do one more. Let's say
There will be no decimals for this, correct?
no. What do you do?
Multiply by I.
Top and bottom by I. Up top I have 6i. On the bottom I have
-11. That's very easy.
very easy, yes? Let's make it a little bit harder. Last concept for today, I promise. Oh my goodness.
You could just click one.
I'm clicking it.
Click it harder.
Please don't smash the screen.
Oh, I know what it did. I accidentally pushed. Okay. My apologies. Let's divide by complex number. Now it's dragging. Do y'all see that? It's not keeping up with how fast I'm writing.
Because you write so fast, you can't keep up.
Come on now, show me.
I was just telling you that yesterday, remember?
All right. Dividing by complex numbers. Here's the difference. Let's say I had 5 over 1 minus 3i.
So then it's going to be 1 plus 3i.
Oh my goodness, good job. Yes. Because you're multiplying the top and the bottom by the what? The conjugate. Now listen to this. This is what I always tell everybody. Go home and tell your parents what you learned today. We are rationalizing the denominator, right? By multiplying the numerator and denominator by the complex conjugate of the denominator.
So the complex conjugate.
Isn't that cool? That sounds real fancy, right?
The complex conjugate is.
I'm sorry. Okay, so we talked about a conjugate is when we change the sign in the middle of a real number, a whole number, and the radical, right? Well, for complex numbers, 2 plus 5i, the conjugate of that would be 2 minus 5i. But since they're complex numbers, I'm going to call them complex conjugates now. This is just a side example. So if I look at my example that I'm running here, and these just take a whole lot of work. It's not that they're so hard, they just take a whole lot of work. So whenever I look at my example here, where I'm dividing by a complex number.
Can you do a square root of complex number on this too?
Do what?
A square root of a complex number.
You could. We're not going to do that here, though.
Which class will you be doing it in?
I don't know that I do that in a class. All right, 1 plus 3i, yes, because that's the conjugate. Now we're multiplying. Now you can imagine if I have a complex in top and a complex in the bottom. It's a lot of multiplying out, right? Biggest thing is go back and every time you have an I squared, remember it's changing the sign of the number. So let's multiply the top. What do you get up top?
5 plus 15i.
Divided by 1
Minus, well,
plus 3i minus 3i minus, yes.
you really have to do it all like that.
No, if you recognize the pattern of difference of two squares, no. All right, so what happens, these are gone, right? Because those are opposites. Look at this. I've got negative 9i squared, but I know an I squared does what to a number? Changes the sign. So this becomes positive 9 because it was negative 9i squared, right?
Maybe 10.
So up top I've got 5 plus 15i, and what does the bottom become?
10.
Does that make sense? Now, in this case, I could reduce this sum.
Yes,
Do you see why?
5 and 10.
Every single piece is divisible by 5, right? And since this is not under a radical, I can also do that. So 1 plus,
3i over 2.
oh, now I'm froze altogether.
Oh.
Over 2. Make sense to everybody? How you feel about it? What you think? Do we need another example? Is everybody good?
So then I could just do negative 9i squared like I did.
Yes, like you did on the board. Yes, absolutely. Absolutely.